So in the language fundamentals, we were looking at the spaces, and we had a variety of options to enter the spaces and how spaces behave while we enter the MATLAB command. So this is what we had seen earlier. And so the line spacing in the output can also be controlled in a specific way. So this is to format line spacing in the output. So output basically refers to the command window outputs only. Okay, so outputs are we see the output in the command window, right? So this actually refers to the command window output. So we have two options basically. That first format is loose, right? Keeps display of blank lines whenever we uh, try to see an output. So first format is called as the loose format. So for this, the command is format loose. So when we enter this command and then we try to get some output on the screen, we will see that we get between any of the lines, we get a few of the blank lines. Okay, so this actually keeps the display of blank lines. This is the first option. Okay, anyway, I'll run and show you what exactly is this. And the second format, I don't want any, this is actually a default. Okay, so I'll write default. So whenever we run MATLAB by default, this is the case. You don't have to specify format loose always, because that's always the default one. But whenever you want to see the suppression of the lines, blank lines between your outputs, so we expect the following type. So if I don't want to have the lines between my display, and let's assume that I want to suppress the output. Okay, so in such case, we have a second format, and this is called as a compact. The second option is compact. So the command to be entered is format compact. So what happens here is it actually suppresses the display of all blank lines. Okay, so let's look at the example of this now in the MATLAB screen. Okay, so let's say the default one is compact, the format loose. Okay, so it's already there. So first let me go to the other one and then we'll see. So I will enter the format compact first. Okay, so format compact. So now actually everything changes to the compact format, and let me enter. So x is equal to, say, sine of maybe this is pi by 4. Okay, I'll do one thing. I'll make this a matrix. So sine of pi by 4 and 3.668. Okay, let me enter like this. So when you see I press enter, you see actually I got a compact output. There is no line space between anything that comes in the command window. So after this first line, right below, next, immediately next line I got X, immediately next line I got this, whatever we entered. Okay, now let me change. So let me go for the format, and right, so the second option I'm entering here is format loose. Okay, now you see, whenever I enter this, I'll try to enter the same thing. So now you see, actually I got the line in between. So you see one line between, then X, then one more blank line, then this. So loose is, right, loose is the other option, which is by default, right? So even if I don't enter format loose, it's always in the deep loose format. Only when you want to go for a compact, you can enter like this. And coming back from compact, you have to use the loose option once again. Okay, so this is how we can format our outputs. Right. Then let's move on to the next topic. And here, in the next option, we will look at about finding the various functions. All right. So let me assume that I don't know the function name. Right. So this is another very useful option, that is to find the unknown functions. Right, so from the command window or editor, using an option called as function browser. So there is an option called as function browser. So we will always click on the function browser, and in the command window or in the editor tab of the edit section, to open a function browser, we'll open a function browser. So let me write that point first. So use the function browser button. So we actually have two options to browse for the functions. The first option is very easy. It is in the command window itself. So we use that, we prefer that. So in command window. So in the command window, just press the function browser button, and then we can find the required functions. So I'll show you that. So let's see here, this fx, what I see here, right? So right, so you can see here there is a fx. This is the function browser. So you can see that there is a shortcut for that. The first option is just clicking over here, otherwise shift F1. Whenever you do shift and F1, function browser will open. So the second option which I told was that. Anyway, just click on this. Right, I clicked on the function browser button now. So as soon as you click over there, a window will pop up. Okay, and that window, over there we can actually type whatever functions we want. So anything that actually, when I click that, whatever comes up, right, we can enter the name of the function I want to find out, and using that I can try to uh, find out the function. So this is the window that pops up, and let me assume that I want to find out the mean. I don't know which is the function. I'll simply enter MEAN. So you see the mean, wherever you find the options to get the mean of certain things, you can find in the functions list over here, right? So you can see that it says that there is a function called mean itself, and how to use that mean, just move your uh, if I moved my cursor over there, I should be able to, right, find out the details of that. So you can simply click on that, right? As soon as I click, right, the MATLAB window will, another window will pop up, and that window will show you what exactly is the detail of that particular function. So as it is, there is no result. But you want to find something means you can type over there. As soon as you type, so one example I told you. So it says sum. So as I enter sum, right, it actually shows you a list saying that okay, there is a function sum which is used to find the sum of sum of array elements. Right. Sum can also be used to find the sum of the time series data, right, etc. So there are other options to take the sum like cumulative sum. Again, another toolbox called financial toolbox, you can use it, symbolic toolbox, etc. You get the complete details of the functions which you can use to find the sum, right? But you have to select the appropriate one according to your need. So it gives you the complete details, right? For example, any other function you want to use, you can use it. So you see that there is one command which we already have used is axis maybe, right? So it says that, right, axis sets the limits of that we already have used. You can see the over there is a program 2, it's actually showing on the screen. You can see that we used axis, so it gives you a detail what exactly this axis is going to do. So whenever I don't know any details about a specific function, you can simply use it, right, like CLC. Okay, so CLC should come saying that. Okay, let me do the clear. Yeah, CLC actually came up now. So clear the command window, right? So the clear is also there, right? So we have many options to use, right? Everything comes up. So the function browser is located at the in the command window, and we can press the FX button to open a window, new window, and we can uh, type the function over there, right? So we don't know what is the exact format to be entered in MATLAB, but still I can keep typing over there just to indicate that this is what I want to do, right? When we do so, right, MATLAB tells you that okay, if you want to do find the mean, then these are the options you have. You can click over there, right, and select the appropriate one from there. Okay, then after the command window, finding out the particular functions from the uh, function browser, right? Let's go for another option. This is also very interesting and very important. It's called as a diary, right? So to keep an activity log of your complete session, MATLAB session, you are running something, and let us say you want to keep track of everything that you did, right? Whichever commands you entered, uh, what and all options you have used, right? You want to track it, let's say so. So in such case, you can use a specific feature of MATLAB that's called as a diary file. This is also important. It's a diary file. So what's the use? It is used to keep an activity log of MATLAB session. So how to use this particular feature of MATLAB? We use a diary function, okay, which creates a copy of the MATLAB session in the form of a text file. So in order to use this, we can use uh, a function. That function is called as diary, D-I-A-R, diary function. So what this diary function does, this is going to create, or it creates a copy. It creates a copy of MATLAB session in the diary, right? So the diary will be actually a text. So you get a separate file created, and that file contains details of everything you entered, everything you used in a particular session of MATLAB. Okay, so this is to turn on, for example. So if you want to write to a diary, this is the particular format. So I write DIARY. You have to specify a name, right? So maybe my session dot, this is OUT. All right, it creates a specific of for the by with the name my session. So if you enter like this, and then you keep entering the various commands on the command window, and it keeps on adding every comment you made, everything you used, every functions you used over there in the command window, and it creates a copy of that into this file by the name my session. So now let us assume that the session I want to finish up, and I want to stop writing to the diary. So you just have to use, so to stop writing to the diary, use a command called diary space off, right? So in a text editor, if at all I open the uh, file by using any text editor, I will be able to see everything that I did over there. The diary will be created, and in that diary you will see everything that you did in a particular session. Okay, so let's see this in a MATLAB screen. Okay, so this is what I am going to do now. Let me clear everything. Right. So I'll do a diary, and I'll give the name my session dot out. So you can change the name as well. So as soon as you create diary space this, you can see on the left hand side, I can see a new file created, my session dot out. And then you keep entering the commands, you do your programming as usual. Okay, a is equal to create a matrix 1 2 3 4. Okay, then we do say b of 2 comma 4. So it creates like this. Then okay, let's stop this. So what I do, I stop. How to stop? So diary off. Now you get this particular session which is present over there, and I would like to open that outside a MATLAB maybe, or let me check, open this as a text. I have an option, open as text. So when we open, we are expecting, see the session is open here, right? It's actually, you can see that the whole session has been entered. So a is equal to, it's a replica of your command window, right? So you can see a is equal to, b is equal to, everything is done until the diary off. You can see that has been typed over there, and it has been saved in the form of a diary, right? So for every session you do, you can, right, create a diary if required. Very special feature. Okay, so until and unless you enter the diary off, the MATLAB keeps on entering the uh, keeps on reading the values that we enter, that we use in the command window, and it will get saved over there in the form of a diary. So that's the next feature. Okay, then right, let's move on to the next option. We visit the matrices once again now. Okay, our intention here is to find the size of a matrix. So we visit matrices and arrays. Okay, and the first option is to find the size of a matrix. So let's assume that we create a matrix and we want to find out its size. All right. So we use a function called size, right? So for example, there is a matrix A and you want to find its size, means you say size of A. It's going to give you the details of that particular matrix. Okay, it actually gives you the size in the form of number of rows and number of columns. So this gives number of rows and number of columns of the matrix A. All right, so that's the first usage. Then let's go to the matrix. So let's see the same thing in. So let's create a matrix. A is equal to 5. So I enter, I create that matrix capital A now, right? And I'll use size of A. So you see the answer comes as 2 and 5. So 2 indicates the first entry, first value is the number of rows. Okay, then we have 5. So the 5 actually is number of columns. So this particular matrix had 5 rows and 2 rows and 5 columns. The size of A returned you 2 values. So your matrix A has 2 rows and 5 columns. So first element of your in the answer is, it actually corresponds to the number of rows. Second entry always will be the number of columns. So this can be applied to any matrix. So for example, if I create, say, B is equal to zeros of, say, 4, so 4 rows and 10 columns, I create B. Right now I find size of B. So 4 space 10. Right, this can be applicable. You can find, right, the size of any matrix and you will get the number of rows and number of columns. So now I have another option. What if I just want to find out the number of rows? Right, I don't want the number of columns, I just want to find the number of rows of a matrix. So the for that reason we use the linear indexing. So I know that linear indexing for my first answer is 1, linear index for the second, and in the answer the second object is 2. So if I use 1 I should get 4, if I use 2 I should get 10. So let's try that. So size of, I want to find B, but I don't want all the answer, I just want 1. 1 indicates is the first one, the number of rows. So B comma 1 is only 4. Similarly, if you want to find out the number of columns of a matrix, you use the value 2 over there in B, right? Get me the second answer, not the first one. So you see B comma 2 is 10. All right, so same thing can be applicable. If I go for a comma 1, it is 2 because a had 2 rows, and in a, if I enter a comma 2, this is 5 because the size of matrix A was 2 comma 5. So you see, using the size command, it's very useful, very easy to find out the size of a matrix. Specifically, you can find out the uh, number of rows and number of columns as well separate. Okay, then let's move on to the next topic. Now let's use another function, and this is to place. Let's assume that we have a set of numbers with us, and I want to create a matrix with those elements as the diagonal of certain matrix. For example, let's say uh, I'll write the function itself. So the function is diag. The function is diag. Right, this is used to place the input elements on the diagonal of another matrix, right? So we use this function. I'll show you how to work with this diag function. Okay, so let's create, say a. I'll create a is equal to 10 minus 23. This is 36 and 88. Okay, so a has been created now. Now my intention is, I just want to put the four elements of A onto the diagonal of some matrix. So you can simply call B is equal to diag of A. So just see what happens. So the four elements which we had in matrix A, right? They are placed along the diagonal of a different matrix. A new matrix has been created and you can put them over there. So this is one of the very useful uh, command. We certain times we need that. Okay, so this is very useful. So that's the diagram diag function. Then let's move on to the next one. So we go for the concatenation, right? Let's see the concatenation revisited. Already, I think we've seen the concatenation option once, how to do the concatenation, right? But now we need to visit the concatenation once again. So this option is matrix concatenation. So we use the square brackets for the concatenation, right? So how to do this? Use brackets. So let me give an example here. Let's assume that A and B already exist, and if I say C is equal to square bracket A and B, so this is actually horizontal concatenation. At the same time, if I do D is equal to A semicolon then B, I know that semicolon says a new row, so new row is below the existing rows, so this is vertical. Okay, horizontal and vertical concatenation is also possible using this technique. So now let's check this on a MATLAB window. right? So let me create A is equal to ones of one row, say 5 column. Okay, this is A, and I create B is equal to say zeros of 1 comma 5. Okay, so let's say we have created this. Now if I say C is equal to, this is A space B, and I close this. See, horizontally they got concatenated, right? So number of columns increased. Similarly, if I want to increase the number of rows over here by do a vertical concatenation, I am supposed to enter, this is A semicolon B. Okay, I don't want to suppress the output, so I remove the semicolon at the end. So you can see that D is equal to, right, 2 rows 5 columns. So that's how we try to perform the concatenation when it comes to the matrices. All right. Then, in addition to this, we have a slightly modified, or we can even use a function for the concatenation. So the function for concatenation is, okay, the first function. Also, there is a function called HORZCAT. It says that horizontally I want to concatenate. Okay, so when I use horizon HORZCAT, it is going to, right, perform the concatenation in a horizontal fashion. So let's check this function now. So let me create A is equal to ones of say 2 rows 3 columns, and let's say B is equal to zeros 2 rows 2 columns. Now I want to use a horizontal cat. C is equal to HORZ cat of A comma B. So let's see, the matrix A is at the beginning, that is 1 1 1, and the second row 1 1 1. The ones are from A and zeros are coming from B. So we have performed the horizontal concatenation like this. So HORZ is the one which we can use easily to perform the concatenation. Okay, all right. Then, so let's move further. Now, let me assume that I want to expand the size of a matrix by inserting a matrix outside the existing index range. For example, let's create a matrix first, and then let me try to understand what we are trying to do here. First, let's create a matrix of a size, say 2 cross 3. I want to create a matrix. So let's say A is equal to, this is 10, okay, 12, 34, 56, 23, 66, 18. Okay, so this is the matrix. So you see the size of the matrix is 2, 2 cross 3. All right. So now I want to add 4 elements to this, right, outside its range, in the sense from say 4, uh, 4 to 6, let's assume. Okay, so we have created a matrix as it is, and I just want to extend its specific one location. So one location I want to add a new number. So that is, so I'll write A of, so third row, and 1 2 3 4 fourth column. See, actually this is not there. 3 comma 4 is not there. A of 3 comma 4 equal to 1, I'll make sure that this is equal to 1. So you see actually that 3 comma 4, the element has been created and a value of 1 has been assigned over there. At the same time, you can see a new row and column has been created to support this, right? A new addition of this. So the size of the matrix has been changed, right? So this is when you want to add a single element. Okay. Whereas you can add a complete matrix to this, right? So let's try to do that now. So what I want to do, I want to add a 2 cross 2 matrix to this outside its boundary, in the sense outside the existing index range. So what I try to enter now, so A of, so you see it already has 3 rows. So fourth row till fifth row, 4 colon 5, you understand, right? And it already has 1 2 3 4. So fifth and sixth column I want to add, so 5 till 6. This is equal to, now you have to enter it two column, that is, say 22 44 colon 66 88. So you see what happens now, the 22 and 44 added as a new row, and 66 and 88 have also been added as a new row. So this is how we can try to extend the size of a matrix, expand the size of a matrix by inserting new matrix. And this new matrix has been added as an extended location. Okay, fine. So anyway, I think similar concept we have seen once earlier, but this addition of a complete matrix is new to us, right? We can use this in the following fashion to get the required expansion of a given matrix.